Quantum Foam, Episode 9, Linear Calculus.
Quantum Foam. Physics. Physics is at the foundation of all the mathematical principles that guide the heavens. You have to understand physics.
More than likely that's not going to happen, but
Forces which govern the universe. Physics.
it truly feels like they are worth that much for some reason. Kind of odd. It's like they're worth a quarter of that. These days, you can basically print that stuff by going to get it for cheap.
What episode is this?
Okay, well, we are covering spin math. This time, gyroscopics, vortices, tornadoes, circles, going around in a circle.
A brand new abstract study of what is called the linear calculus. The operating instructions for a 64-qubit quantum computer is written in this new notation.
Basically. Now, this is a fairly old
Gotta be joking.
discipline of study. It goes back thousands of years, actually.
He's serious.
But basically, manufacturing has used different forms of spinning machines for a very long time. And so this concept is fully understood by hundreds of people, thousands of people, millions of people in the past have understood this at a manufacturing level. Millions of people. That is why you go to a factory and often there are machines in there that are 50 years old. And how did they even have electronics back then? Oh, they did. But what they are is more than likely it's a mechanical machine that has been modified with upgraded electronics.
Let's see, you probably took a computer unit home from one of the machines at one of your old factory jobs and examined it, and you had an electronic engineer verify. Since, you know, we don't all understand every last component in a computer system, but we understand that they work
To run
system on a chip.
the machine a different way than in when it was originally designed. So what exactly are these
Hey, stop messing around and get back to what we were talking about.
torsions? What is a torsion field? This is some of the stuff we're going to get into as we try to describe the reasons we need essentially a new math to keep track of this stuff. I mean, you go to the internet and you're flooded with
Fake bullshit. That's what.
so much.
Quacks left and right. Gotta love the internet.
So many videos of all these people talking about all this stuff, and half of them are full of shit. You're full of shit. Full of shit. I am full of shit. I'm joking, bro. I'm not even joking. We are talking about combining a concept into a completely new concept in the form of a different set of rules to be read off a rubric and enacted out in a sequential fashion, yielding a metric of a bunch of numbers that is going to tell us in a certain way, a certain thing. That's how humans tend to do things. They can consolidate one concept into a group with enough input and enough good work. What is this new form of math that we are trying to
Learning linear calculus.
develop in order to even speak about some of the complicated concepts that we are going to be speaking about and that we have already spoken about? The information contained within this sound wave is very important. I am attempting to write a scientific backed, mathematically backed book written in a nutshell fashion,
Layman's term.
a book written in a brief fashion, a synopsis of the most important ideas, a synopsis of
Everything.
the most relevant information, a relevant history of mankind. I've read that book too, actually.
That book was written by Nathan Scherf from 1998.
There's lots of history books. People write history all the time. They are constantly constantly rewriting and writing history. History is constantly being revised. There are things that are getting left out. There are books that are getting burned. There are ideas that are getting killed. There are things that people are hiding. This is an attempt to, by its very nature, consolidate. This is an attempt to group up similar adjacent concepts. And mathematics, by its very nature, is so confusing and is understood by such a small portion of each individual population that this is one of those things that is about hiding in plain sight. It is hiding in plain sight under the guise of math and a bunch of technical jargon. There's a point where you start talking about, okay, the lattice on this quantum vortice, okay, is, okay, inaccurate, inaccurate, okay, inaccurate, what, inaccurate, what, inaccurate. If you just, inaccurate, say this, inaccurate, to somebody, what, inaccurate.
We get the point. You are creating matter out of a new math. Sweet.
They're gonna say, the fuck are you talking about? The hell's a lattice, man? Are you talking about lettuce? Like you're gonna eat a sandwich like a BLT, bacon, lettuce, and tomato sandwich? What the it's like a hex thing. It's a grid. What's a cool way of saying grid? I like saying that word too. Lattice grid. Basically, what are you talking about? Somebody starts talking and they're tuned out immediately based on the fact that they're starting to spit out a bunch.
Focus. Get back on task. Stop wandering off with other stuff. Get back to the sound wave.
A bunch of random technical mumbo-jumbo bullshit. The way my brain is currently working, it is attempting to group together several randigal words within a paragraph. Randigal into one word. Randigal.
What does that even mean? A conjunction between random numbers and a graph showing infinitesimal data. That is too technical.
This is going to be impossible to do at that level because I wouldn't even understand it. And then nobody would know what the fuck is going on. I'm attempting to explain a very complicated concept in layman's terms, in a nutshell, in a brief, in a synopsis, in a report, in a interpretation, in a analysis. I'm analyzing everything I have available to me and am formulating potential experiments, potential theories, potential formulations of ideas, a potential new form of math that may help its accompanying fields. It may help its sister field of physics. Physics may understand math, but does math understand physics? Physics. Does your mathematician understand your astrophysics, your geophysics, your metaphysics, your biophysics, your fundamental physics, your materials physics, your experimental physics, your professional physics of some kind? Does your physicist understand the high-level theory physics that mathematicians on a professional level are attempting to solve?
I always rather fancied myself as more of a mathematician than a theoretical physicist.
Solve proofs that have not been solved by any humankind and recorded ever. What is the forefront of your physics, mathematics? The forefront of mine, mathematics, are that they haven't even been written yet, mathematics. I've had mathematics, formal training in mathematics up to certain levels, mathematics. Those levels probably are not as high as your professional mathematician and your professional physicist would do, but don't we basically pay other people to do our math? Don't we basically buy a computer and enter in a formula and have it calculate our math? Physicists, don't we have something else do our math? Physicists, do we understand what math we're doing? Do we understand the math that we are doing? Do we understand the math that is being done by the computer? Have we analyzed these data points? Are we actually just looking through data sets and trying to form conclusions out of them? Is that the real work of astronomy? Is that the real work of...
Are you sure you don't have an LTD?
Is that the real work of astrometry? Individuals who work with astronomy on a professional level.
They give all of us the images from space after being processed correctly.
I am so glad for that other podcast because that would essentially be your PG version. Maybe even your, what is that other one? What's the kid one? Rated G version of a listening program. And so much information has been given on that program and most of it's accurate. I mean, the important things, it's like, oh, you said this number was that one and that number was this. These don't matter. Somebody might take it as fact and be incorrect, but I don't think it's going to be your leading such and such director of this physics department who is going to hear that detail and mess up some of their work because of it. It's unlikely. So other programs like that are a little more acceptable for being played in public and such. I am attempting to keep this podcast up to and including PG-13 and some R stuff, but not rated R. I don't want a full adult version of this.
LOL, like a sex story every 5 minutes. Get your mind out of the gutter.
Because then there's too much garbage. The reason why I get into the comedy and the other vulgar things and the other very inappropriate shit I'm saying, cussing, sexual references on a minor level, suggestive word combinations.
This is what Michael Savage calls
psychological nudity.
Implied innuendos, subtext,
psychological nudity.
Context.
Psychological
nudity.
Basically, sub-important information that is mixed in with the science and the other messages attempting to be sent by this transmission. Basically, I'm going to cuss a little bit. This is being taken as a sort of real-world approach since I am doing what I'm doing. I'm creating a pool of voice data and writing a thesis and potentially inventing a new way to study artificial life. Or a new way to study computational physical analysis. Another way to do modeling that others can use for various purposes, scientific, entertainment, other purposes. People need computer models. They need models. They need frameworks. They need somebody to create the interface for everybody to use in order to be on the same page and even have a virtual group all over the world showing all the videos of everybody in their respective places and allowing them to do meetings in different places on the world where we can't get to.
That's how you can even treat the technology that we have today.
Or don't have the money or time to get to. Back to, what is this spin math? What is this spinning mathematics? What is this linear calculus? The way I denote it is a integral S, you know, the famous integral symbol, and then next to it, a certain lightning bolt appearing version of an S. The S is sort of for summation because I believe the other integral S-looking symbol is also for summation. So this linear calculus is a summation, which is a matrix, linear calculus, which is a summation, matrix, linear calculus, which is a new container that I am describing as linear calculus. We already have tensor calculus. We already have infinitesimal calculus. We already have other flavors of calculus. We have linear algebra. That is matrix theory. What is linear calculus? It doesn't really make sense. Linear calculus. But linear calculus. It is what I'm referring to this as. It is a flavor of math. The naming does not matter. The mathematics is what matters. What are all these things? These are phenomena dealing with gyroscopics. They're quantum vortices. What they found in that one show and it was stolen by the government? No. That probably would happen in real life. Maybe it did happen in real life and they're like, yeah, this is funny, but this is our stuff. You can't develop this any further. You do not have the authorization. Your security clearance has been demoted. Your security clearance has been revoked. You do not get security clearance. Revoked. Even Einstein didn't get security clearance because he was German, even though he was Jewish. Like, what? Even after what they did to that country? Yes, the Holocaust did happen. There are pictures, there are books, there are people still alive who have told people who are still alive, who have told people that are still alive, who were in the Holocaust. Auschwitz, another one.
Auschwitz. That one is hard to pronounce. There was also Buchenwald. Remember what happened to the people responsible?
These people were hung, okay, in front of the world. It happened. Moving forward. So these things can be described as torsion fields. Think of a torsion as, you know, a spinning bike. You're riding a bike. It's going forward. There is an invisible stick that is orthogonal to
an outward pointing vector, one that is perpendicular, or like, at a 90-degree angle, or pi over 2 radians.
The plane in which the tire is spinning. You're looking at a graph, XY graph, 2D. You got a circle on there. It's going going counterclockwise. So it's going counterclockwise. You use the right hand rule. You use your hand. Look at your hand. Your thumb is facing up. Your hand's flat. Your hand is flat vertical, not horizontal. Your thumb is pointing towards your nose. Move your fingers in. Your hand is flat vertical. Close your fist. The direction that's going is counterclockwise. The direction of your normal force, your torsion field, your vortices that's sticking out of the side of the tire in the center. Your normal force is going to be in the direction of your thumb, upward. They just call it a right hand rule so that herf derf.
They just name it that way. And tops spin downward.
Yeah.
No.
But yes, that is how you do the right hand rule.
So a spinning circle has a normal, like a top.
Sounds fun to try. We gotta take a break.
We're at the midpoint
Of
episode 9, linear calculus.
Of
A counterclockwise spinning disc has a,
this is also the same thing as light cones.
let's say we spin it.
This is also how they denote so-called particle parity and the initial isotopic spin direction.
mathematics.
Let's say we spin it. My right hand, I would probably spin it clockwise, in which case the normal will be down. That is why the top can spin on a tip and not fall over for a certain amount of time while it's spinning. It is creating a torsion field. So think of a torsion field like a tornado, like a T. You spin it around and it's like a little mini helicopter. So it's easy to imagine this. Basically, it's a torsion field. It's a tornado. It's a spinning thing. It's a gyroscope. It is a spin math thing. So one thing that is very peculiar is that people are aware that you point a sensor in a certain spot in the sky and you know that you're accurate enough to verify your work. There have been people who have pointed sensors at known paths of celestial bodies and they are receiving feedback from that. And then they cross-reference that with other areas that we know have been blank in the sky at this certain coordinate on the underside of a dome. And like your zenith is straight up, the dot that's straight up, let's say that's blank. You point your sensors there, they don't receive feedback. And so what is happening here? Let me attempt to explain. What we are doing is, if
There is.
a such thing as gravitons spinning
There is.
objects
There is.
tend to actually emit what probably is a torsion field.
There is.
Probably is created from a bunch of graviton point particles. And they can be modeled using a flavor of tensor calculus. And so basically that's relativity stuff. You are trying to measure paths of bodies. Potentially your spinning torsion field at a certain rate can also be modeled as a point particle with this mass and these numbers. So what is even possible here? We're measuring paths that move at a constant rate. We measure some paths that move at accelerating or decelerating rates. So what we want to do here is they have linear algebra systems. There are CAS systems, computer algebra systems. It is basically a table, an index that has been previously calculated and verified, stored in a small form of memory, binary digits in a text file, as a list that can cross-reference this to that, a column and a column, and a shit ton of rows. Column, column. One of them is A, one of them is B. You're referencing A with B. You're checking B with A. Back and forth and back. Essentially, you're doing a Google search for a math solution, and it is sending it to a supercomputer. The supercomputer is putting the formula request into their mainframe, and each transistor and logical transistor built within the computer system is essentially adding 1 plus 1 plus 1 plus 1 plus 1 plus integral plus integral plus integral plus integral series this infinite amount of times or enough times to create a certain requested degree of accuracy. You're asking your computer just to do addition, yet you're doing complicated calculus. So that is what the table is.
You would think that somebody would have already come up with this idea, but I don't think it has been written in a way where a new universal container of mathematics can be stored in a linear plane. Not a brain, either, or AP brain.
So we are attempting to create a new discipline of a linear calculus table, a linear calculus system. It is a new discipline, new field of study. It can be looked at as an advanced matrix theory, a new grid. So another thing we have breached upon is, why is the growth rate 2.7 something? Why don't we have a different growth rate? What is missing within that growth rate and what we see as our spiral galaxies? Why does somehow our galaxy spinning is causing its own warping of the box that can be said to be around our entire galaxy? So inside this box, which is the local group. We're in the local group of our local group of galaxies. And so let's say this box goes around our galaxy. We are now describing what can be described mathematically as a wheel, like a tire, some sort of disc, some discus that can be looked at as a 2D circle, a 3D sphere, or a 4D tensor calculus backed torsion field representation. Essentially taking into account that what we're doing here is we're trying to compare a background independent reality with background dependent string theory math, finite math. We are trying to turn infinite math into finite math. We are trying to do infinitesimal calculus with torsion calculus and figure out a way to write new metric tensor calculuses in the form of a linear algebra system that can be described
as a new discipline.
And one may say, how do you understand this stuff? What is different about your flavor of understanding? There may not be much, but
If there wasn't, then I would not be here.
what I can say is that I understand this stuff in my brain completely. I understand how objects spin. I understand what direction the normal's going to be in. I understand that gravity is down. I know how fast it accelerates. We all do. But what I know is I get real-world feedback. I can see real-world feedback from the graphical representations of information and mathematics in my head, as well as use my hands to fully grasp the concept and the sensation of spinning gyroscopics. What I mean by that is I can spin two strings with two balls on them in a circle fashion, splitting up the particles with their accompanying strings, which essentially would be a ray from the center of that circle to the end of the mass, the ball, spinning in a certain direction and at a certain speed. Essentially, I'm spinning poi. I started my studies 10 years ago with that as a hobby, spinning fire, spinning glow poi, flow toys, e-poi, all kinds of toys they got these days. And my version that I'm going to try to invent is this orbit poi. And the idea with that is there are two separate readings of sensors, orbit poi, being fed into a game engine. I'm attempting to create a virtual reality game, orbit poi, that can display sort of a virtual reality version of this with enough sensors, infrared motion sensoring and gyroscopic sensors that we can battle ourselves and other people and computers.
I see. Predictive artificial intelligence. FTL math.
Nice.
And so, in order to do all of that, the math has to be written. These are simple paths of particles that are spinning. They can be modeled as partial differential equations or differential equations where enough variables are known to do the math. They can literally do the math down to a certain degree of accuracy with pool tables, pool balls, billiard balls. That is the point of that entire game. It's fun to be able to actually make your hands use a stick to hit a ball in a certain way and get it in a pocket. That takes some serious skill. I'm not even very good at it. Some people I know are. And so I understand the spin math, these gyroscopics. My hands understand it and my brain understands it too. So I believe I understand what I'm talking about. Most of this stuff has probably been written before. Let's say I have a 16-bit depth of an image of this sound wave. I also have a sample rate.
Essentially the resolution.
Sample rate.
The native resolution.
44.1 kilohertz, 44,100 hertz rotations per second. So we're talking about spin math. So let's talk about that spin math. It's spinning around 44,000 times a second, essentially. And that is enough of a resolution to be modeled with tangent graphs where the asymptotes are all taken care of. Each sample is just a complicated tangent graph. Not even that complicated. Each tangent graph sample is a simple tangent graph, a tangent graph of something that is mimicking a representation of the sound wave. There are different aspects and different views and different representations of the spectrum of these waveforms. Astronomy likes to look at the spectrum because it tells you more information. But the information we need for a sound wave is basically the amplitude and the sample rate and all of that compared to a rate that can be described as the sum of the area of
Like the length of the sound wave, basically. So if you make this podcast with the 500-hour image recording at 16-bit color depth and 44,100 tangent samples per second of elapsed time according to a timer or stopwatch of an observer who is viewing, listening, or examining the entire 500-hour sound wave, which then has been transmitted and received in an entirely new universe and space-time scenario.
You know, the calculus sums.
That universe belongs to those observers alone. This would also mean that your sound wave waveform recording is accurate up to 1 millisecond, or 0.001 seconds.
All of the Riemannian sums.
That can be viewed as a linear calculus of an approximate representation of an entire cosmology, which we can refer to as another universe in another space-time continuum.
The rectangle under the curve infinite times. The area of this entire sound wave is this. Is that the scalar quantity that can describe that sound wave? These are questions we are asking. A lot of this stuff has been checked even before now. Do you even understand orbital mechanics? Do you even orbital mechanics, bro? Okay, this is what we have available here.
I can't wait until they have holograms for this stuff.
Okay, we got 3 4K monitors, but we just use these 2 here. We have 2 4K 28-inch flat screen monitors. They are being ran by one Asus 1080 Ti fairly top-end graphics card. It can run them just fine. We are modeling orbital mechanics down to a Newtonian level. Who does the relativity math then? We have to do that. Why can't we do it with the program? We might be able to. This is such a complicated program that it has been decided that we can trust it at a degree of accuracy down to a Newtonian level. For normal orbital mechanics, where you model planets and other astronomical structures as point particles, this is accurate enough for our purposes. So we are able to go forward and backward in time and study different interactions with different scenarios with solar systems that can be modeled off of our own and created in a different capacity entirely too. And so most of this stuff has been checked, and I think we are at a point where we can write a different understanding of only the math that is required to do the work we need to do.
So much work, so few who can do it. Step it up, people.
Who understands this stuff? Nobody does, man. That conjecture is still there. They proved these ones, but there are more out there, and we just simply don't have the computing power to do it. They're into billions of digits of pi.
These days they say that the Google compute engine has indexed 31.4 trillion digits of pi as of 2019, but in 2024, they now know 202 trillion digits. It keeps going up.
We don't care, man. We don't care. Is that how far we're seeing how round a circle is? Like, what does that even mean, man? The resolution of how many times we can 360 degrees. I'm attempting to describe everything with only a certain amount of unknowns.
The big picture is, you are giving a new set of mathematics in order to discover and describe the most up-to-date and current understanding of what you call linear calculus. This new discipline is a prerequisite of the very complex and multiplex nature of a new method with which we may be able to more precisely calculate the proposed image recording of our universe. This thesis is expected to be thoroughly reviewed and inspected at a quantum foam level below the current magnification scope we have available to us today, the Hubble Space Telescope and the ground-based spectrum observatories that as a whole observe the rates for the remaining frequencies beyond visible light. This is what we have today. What we will have tomorrow is the new space telescope that will see in the infrared.
The James Webb Space Telescope.
This is the future. Everyone is hoping for the successful placement along the L2 Lagrange point. The thesis describing a new theory of everything is put to the test solely for the purpose of proving that there is a new formulation of mathematics required in order to properly understand higher order cosmology. This is the most complicated scientific description of everything that has been offered as a solution for the consolidation of quantum theory and relativistic understandings. This is the largest problem in our current region of space-time.
We will breach upon a little less complicated topics at a later date. Basically, a much larger
theory of everything
amount of certainty at a later date. And the information we have provided for this panel of review is comprehensive enough to explain the main ideas of linear calculus. And in addition, giving it a funny people presentation in a funny light, in a comical light, in a brief enough way that these assholes will listen to me. All I can do is provide the information, and here it is.
Basically, this is the introduction of a new mathematical formalism which uses audio containers to deliver problems and solutions using the quantum mechanical supporting notation of linear calculus.
That is it today. We will finish up our first 10 next time. This is it for episode 9, Linear Calculus on Quantum Foam. Quantum Foam.
The zeroth wave disclaimer.
The views and opinions expressed in this podcast are those of the author or authors and do not necessarily reflect the particular views, thoughts, or opinions of Zeroth Wave Productions, any of its sister companies, its parent company, Zeroth Enterprises, or any other entity which had existed, will exist, or which, quote-unquote, presently must exist outside the realm of our current space-time.
Quantum Foam is produced by Zeroth Wave Productions.